Welcome back to the Deep Dive, where we tear apart the most earth-shattering scientific papers and figure out why they still influence, the research you read and the technologies used today.
Today, we are diving deep into a paper that really provided the essential instruction manual for modern quantitative biochemistry. It's the 1951 masterpiece by Lowry, Rosebrough, Farr, and Randall, titled Protein Measurement with a Folin Phenol Reagent.
Right. And if you've ever been in a wet lab or even just read a paper about enzyme activity, you know you have to quantify protein. It's fundamental. This paper established the method, the Lowry assay, that became a pillar of the field for, half a century?
It truly did. And the historical context here is really crucial. The core chemical, the Folin phenol reagent, wasn't new.
Oh, really?
No, it was proposed decades earlier, back in 1922 by Otto Folin and Wu. It showed a lot of promise. I mean, amazing sensitivity, simple procedure, but it just hadn't caught on. People found it a bit temperamental.
So the mission of this 1951 paper wasn't really invention, it was more like taming.
Exactly. Taming is the perfect word. They took this difficult, quirky reaction and figured out every single variable, the pH, the timing, the concentrations, to enable its, and this is their phrase, fullest exploitation. They turned a novelty into a tool.
And what a tool. I mean, the sensitivity they talk about is just remarkable.
It's incredible. They describe procedures capable of measuring as little as zero point 0.2 gamma of protein.
And for anyone not up on their old school units, zero point 0.2 gamma is 0.2 micrograms.
Precisely. Microanalysis territory. To reliably detect protein at that level in 1951, before all the modern equipment we just take for granted, it's astonishing.
It just fundamentally changed the kinds of questions researchers could even ask.
It gave them a massive advantage. But all this sensitivity came from a combination of two distinct chemical processes. You can't just throw the Folin reagent at the protein. You have to prep it first.
Okay, let's unpack that, this two-step process. Walk us through step one. What's the prerequisite for getting that color?
So step one is the alkaline copper treatment. They used a specific mix they called reagent C for this. Basically, you mix your protein sample with copper ions in a really alkaline solution.
Right.
This is where the magic really starts.
The copper preparation, that's the key to amplifying the signal, right?
It's everything. How significant is it? Well, the raw Folin reagent mostly just reacts with a couple of amino acids, tyrosine and tryptophan. But when you add copper and alkali first,
What happens?
you get a massive 3 to 15-fold increase in the final blue color. The copper is a sensitizing agent. It lets the next reaction pick up signals from the protein's peptide bonds, too.
So the copper isn't just helping out, it's the core multiplier that makes the whole thing so sensitive.
Exactly. Without it, you're missing most of your signal.
Now, I know there's another copper-based test, the Biochemistry reaction. Is this related?
It is, chemically. The Biochemistry is also based on copper complexing with peptide bonds.